Hello. So this video is going to be going through the quadratics unit, which I created for my Algebra 2 students for this particular year. So this is actually, there's not going to be any graphing in this video. So this is going to be, it's going to start off with factoring quadratics. And it's going to be a two-part series. So part one is going to be all factoring. Part two is then going to be solving after factoring. So I started this packet off by going over the three forms. So you got standard form, f of x equals ax squared plus bx plus c. This is the form that we're going to start off with most of these problems in, and then factor from there. To get factored form, which is, some teachers do it differently. I just use r for roots. So minus r1, root 1, minus r2, root 2. Then you got your scale factor out there. Vertex form, again, there's not any graphing. Vertex form is great for graphing. There are a few problems in part two where we'll be solving from here instead of putting it into factored form to solve. It's easier sometimes if you have it in vertex form just to solve it using square roots. So that'll be in part two. So to get into this, what are solutions? So I usually start the quadratics unit off in Algebra 2 by going through graphing first, graphing x-intercepts, y-intercepts, the vertex, all that. So now getting into solving a quadratic, solutions are the x-intercepts. Okay, so solutions are the x-intercepts. There's two real solutions. Now that'll come up. There are imaginary solutions for quadratics. But if it has an x-intercept, then that is the real solution. That means there is, you can see it. It's real. It crosses the x-axis. It has an x-intercept. And then I put here the other terms for x-intercepts. So solutions, x-intercepts, zeros, and roots, all the same thing. So there's two real solutions because there's two x-intercepts. Here's an example of a quadratic function or equation that would get you one solution, one real solution. And that's because it touches, it doesn't cross, it just touches at -2. So it touches the x-axis once. And then here, I'm not going to cover this two-part series is not going to cover, I mean, actually down the road, I'll make a third part to this. But I guess so part 3 or part 4 will cover imaginary solutions. Imaginary solutions are when it does not cross the x-axis. There's no real solution. It doesn't touch it, doesn't cross it. So we have 0 real solutions, but there will be 2 imaginary solutions. And again, that'll be a later video, not in part 1, part 2. Part 1, factoring, part 2, solving, probably, I want to say part 3 will have imaginary numbers. Okay, so to get into this, just factoring stuff, right? No solving. This is not an equation. This is an expression. There's no equal sign. This is an expression. So we're going to factor this expression here. And yes, this one's not a quadratic, but still to get the idea of factoring out a greatest common factor. So a GCF, greatest common factor. So here's an example. So what's the greatest common factor? Now, what's really important is if there's a negative in front, or a negative in your leading term, your leading coefficient, you want to factor that negative out. So I see that I can divide both of these numbers. I can factor out a -10 because -10 goes into -10 and -10 goes into -30 3 times. So if I factor out a -10, which factor means to divide, right? I divided it out. What's -30 divided by -10? 3. What's -10x divided by -10x? So when you factor it out, you get -10. And vice versa, if you were to distribute it back in with multiplication, you would then be back at -10x minus 30, right? So here, you're dividing the -10 out, and then what you do before is you multiply it through. So how do you get rid of multiplication, division? You're just dividing it out, you're factoring it out. So let's move on from that. So example 2, here's an example of a quadratic. So greatest common factor. So you're looking for the most or the greatest thing which you can factor out. So the greatest number I can factor out of this is a 2. So I can factor out a 2 out of 2 because 2 divided by 2 leaves me with 1. There's a little invisible 1 right there. That's 1x. And I can factor 2 out of 8. 8 divided by 2 is 4. Now I cannot factor out an x squared because this term does not have an x squared. Now, up above, if I was to write this out, this would be 2x times x. So this has 2 x's being multiplied together. This one just has 1. So the greatest I can factor out is a single x. So that's why instead of factoring out a 2x squared, you're factoring out just a 2x. And again, you factor that out and you're left with, oh, x plus 4, and you have 2x on the outside. So you're going to see that a lot, that what's left on the inside becomes 1, and then you got this out, which becomes a separate thing. Example 3. So now my students are getting to the point where they're going to have to start solving. Well, really, they're just going to watch this video and fill out this notebook themselves, just like you are watching this video. So what's the greatest common factor here? What can I factor out? Well, I don't want there to be a negative in front. So that's the first thing I'm going to factor out. So I'm going to factor out the negative. And I can divide out a 3 because 3 also goes into 27. It has to, whatever number you divide out also has to go into the other number. So 3 goes into 27 and 3. So I'm going to factor out a negative 3. Can I factor out an x? No, I cannot factor out an x. So this, I don't know if I made a typo. Probably me. Yeah, I made a typo. That should be an x squared, and that should be an x squared. All right, that's good to remember. Glad I made that typo, actually. That's the point of I can't factor out an x out here. That's still x squared. That does not change. Can't factor it out. This 27 doesn't have an x. There's no x to factor out of this. So it's not a greatest common factor. What's 27 divided by negative 3? Negative 9. What's negative 3x squared divided by negative 3? Just x squared. So I get negative 3. So if I was to write that a little bit more pretty, I would have negative 3 x squared minus 9. All right, you factored out a negative 3. Negative 3 was the greatest common factor that you could factor out. All right. Go up to the top. So now we got a quadratic with all 3 terms. So we got a trinomial, 3 terms, trinomial. What's the greatest common factor we can factor out of here? Well, I gave a hint of, you got 2x left. You got, I messed up again. This one needs to be 2x squared left, 4x, and negative 3. So, well, what do you divide 10x squared by to get 2x squared? 5. All right, and the greatest common factor here is again 5, because everywhere you should be dividing out a 5, but this should be plus. Don't need to put a plus in front of that 5 because there's nothing to add it to in front of it. So that's the greatest common factor, and then when you factor it out, you get 5. Right? 5 goes into all these numbers. 5 goes into 10 twice. 5 goes into 20 4 times. 5 goes into negative 15 negative 3 times. So moving on. This one I did the opposite way. I gave my students the greatest common factor. So divide that out. What is 7x squared? Not 7x squared. What is 35x squared divided by 7x? Well, 35 divided by 7 is 5. And x squared divided by x is x. What is negative 21x divided by 7x? Well, the x's cancel out. And negative 21 divided by 7 is negative 3. So I am left with 5x minus 3. So that is my factored form, 7x times 5x minus 3. All right. So that's greatest common factor, factoring out just a number or a variable, the biggest term you can factor out. Now we get to a point to where we have to factor out more than just a single term. We're going to be factoring out a whole binomial, two terms. So factoring quadratic expressions in standard form when a equals 1. When a equals 1, when the a value is 1, you don't have to put it there, right? This is technically, hopefully, if you're a student in Algebra 2 or even algebra, you would know how many x squared this is. When you don't put a number in front, by default, it's 1x squared. All right, so we got 1x squared. You don't have to write it. Mathematicians are lazy, don't want to write it. Well, I don't want to say that. I don't want to get in trouble for saying mathematicians are lazy. But 1 times x squared is just x squared. Don't need to write it. Feel free to if it helps you though. So factoring. This is the method which my students are learning this year. So we draw a little x, you put c on top, the c value on top, the b value on bottom. And what you do is you want to find what two numbers multiply to be 38, but adds to be 21. All right, but adds to be 21. So what multiplies to the c value that adds to the b value? So what are some factors of 38? I'm just going to split it in half. And that would be 2 and 19. So 2 times 19 is 38. Is 2 plus 19 21? It works. So that's what I got. I got 2 and 19. So those become my two factors. So I get x plus 2 and x plus 19. All right, easy peasy. So you set up little x, you put c on top, you put b on the bottom, and you want to find what numbers multiply to 38 that add to 21. What numbers multiply to the c value that add to the b value. All right, so let's go through. How many examples do I have of this? Quite a few. So we got our c value, negative 45. We got our b value, positive 12. What are some factors of negative 45 that add to 12? Well, first off, when you have a negative product, right, because we want to multiply to negative 45, so that means product, one of the numbers has to be negative. So one of these numbers has to be negative. And I've done this long enough, and hopefully students learn this by doing this enough that you learn this, that when you add a negative and a positive and you get out a positive, the positive number has to be bigger. So whatever numbers I'm looking for, I want the positive number to be bigger. So can't cut 45 in half. It's odd. I mean, you can, but it doesn't give a whole number, and we're looking for whole numbers. Because I made these problems easy for my students because they're just learning it. So let's say you can divide by 3. So negative 3 plus 15. Does that equal 12? Yes, it does. So those are my numbers. Negative 3, positive 15. Negative 3 times 15 is negative 45. Negative 3 plus 15 is 12. So I get negative 3 and plus 15. I want to revisit, I guess not revisit, I haven't said it in this video yet. Order doesn't matter. I could do x plus 15 and x minus 3. Doesn't matter. All right, doesn't matter. Just put them in one of them. X plus 15 times x minus 3 or x minus 3 times x plus 15. Order does not matter. Multiplication is commutative. I hope I said the right property. Okay, so what multiplies to 20 and adds to negative 9? So again, this is a different one. So there's two types of numbers that give a product of a positive. So a positive times a positive is a positive. A negative times a negative is also a positive. So another little side hint is when you have a product which is positive, but you want the two numbers to add to be a negative, both numbers are going to be negative. Because a negative times a negative is a positive, and a negative plus a negative is a negative. All right, so what numbers? I'm going to say -4 and -5. -4 times -5 is +20. -4 plus -5 is -9. And again, order doesn't matter, so I could go -5, -4. Order does not matter. All right, x minus 5 times x minus 4. Here's an example where a is not equal to 1, but doing what we did at the very beginning of factoring out a GCF, a greatest common factor, we can get it equal to 1. So I can factor out a 2 because 2 goes into 2, 2 goes into -6, and 2 goes into -4. And I'm just going to keep dropping that 2 down while I factor. So now, not even looking at that 2, and I want to just factor this, my a value is now 1, right? I got a little invisible 1 right there, 1x squared. What multiplies the -4 that adds to -3? And again, when you have a product that's negative, one of your numbers has to be negative. This time, I want them to add to be negative. So the bigger number is going to be negative. And I'm going to say it's going to be -4 and 1. -4 times +1 is -4, and -4 plus 1 is -3. So -4 plus 1. So that whole thing is your answer. You need to keep the 2. The 2 doesn't disappear. Later on, when you're solving, and we'll get to that in part 2, when you're solving, you can just divide it out. But for now, you factored it out, and it needs to stay there. You can't just let it disappear. It needs to be part of your answer. All right, so that's factored form. Okay, now what happens when a equals, or when a is bigger than 1, but you can't factor it out? You can't, it's not a GCF. You can't just divide it out. So this is factoring a quadratic when a is greater than 1 and you can't factor it out. So we're going to be using the AC method. Actually going to zoom out, see if I can fit this whole problem in. Some of these problems get pretty long if you don't skip any steps, and I'm not skipping any steps in here. So AC method, I can't divide the 3 out. 3 does not go into -2 or into -5. So I can't, it's not a GCF. I can't divide it. So we're going to use the AC method. The AC method means you multiply A and C together. So I take my A value, which is 3, right? I take my C value, which is -5, and I multiply them, and I get -15. Once you do that, it's the same process here of what multiplies a -15 that adds a -2. So again, the product is negative. So one number is going to have to be negative. This is negative, so I'm going to want the bigger number to be negative. And I'm going to say we want -5 and +3. -5 times 3 is -15. -5 plus 3 is -2. Now, unlike before where we would just separate that into x minus 5 and x plus 3, we don't get to do that here. What we're doing is we're going to take these two numbers and we're going to separate out this -2x into -5x and a +3x. All right. Now, why are we doing this? Well, because isn't -5x plus 3x -2x? Yeah. And I have a lot of students that normally comment, well, why'd you make it bigger? You made it more complicated. You added stuff to it. Yes, but now I have 4 things, which is an even number, which means I can group the first 2 and group the second 2 together, which there is a point to that. So we got -5x. We have a +3x here. I always group the symbol. I always group the symbol in with the second term, or I mean the third term. Always group in the symbol. So now we're going to look for GCFs, all right, greatest common factors. So what is the greatest common factor in this, out of these two, out of this binomial, these two terms, which I can factor out? Can I factor out a 3? Does 3 go into 5? And nope, can't factor out a 3, but can I factor out a variable? Can I factor out an x? And the answer is yes. I can factor out at most just 1x, because this has 2 x's, this has 1x, so I can factor out 1x. That's the greatest common factor. I'm left with 3x minus 5. Now here, I can't, again, same issue, I can't divide a 3 out. 3 doesn't go into -5. I get 3 divided by 3 works, but 3 doesn't go into -5. At least it doesn't go in an even amount of times. So we're not going to divide that out. And actually, what you see is this and this are the same, and we want those to be the same. So I'm actually just going to drop this down because it's the same. And if you can't find a greatest common factor, there is always one number that you can always divide any number by. Well, there's actually 2. Well, no, never mind. You can't divide by 0. Doesn't work. You can always divide by 1. Well, I mean, you can divide by any number, but you can divide by 1 and that doesn't change anything. When you divide by 1, that doesn't change a number. All right, so I can divide out a positive 1, and that doesn't change anything. 3x divided by 1, 3x. -5 divided by 1, -5. So when you don't want to change something, when you don't want to change something at all mathematically, divide by 1. Or multiply by 1, but in this case, we want to divide it out because we're factoring, so we're dividing it out. Okay, so what you notice here is these 2 things are the same. And I tried to on this packet, you see how the blue line, black line, black line. So they're supposed to go together. So I'm going to put the 3x minus 5 here. Those become one term. And the x and the plus 1 becomes the other factor. So the reason for this is, the reason why this works, and some students don't see it right off the bat, is distribution. If I was to take this whole thing and multiply it through this, there's 2 terms inside here. So just like I'd have to, if I had 2 times x plus 1, I'd have to distribute the 2 to both terms and get 2x plus 2, right? You do the same thing here. So I'd have to distribute this whole thing there, and I'd have to distribute the whole thing there, which is what you see here. You got the x times the whole thing and the positive 1 times the whole thing. So you just factored that stuff out. You factored out a binomial out. Hopefully it makes sense. Maybe it clicks a little bit. Maybe I'm over explaining. Anyways, let's move on. Got a few of these examples. So we got the AC method again. Can't divide the 5 out. Can't divide the 5 out at all. Can't divide any number out. There's no GCF to start off with. 5 is a prime number, so if you can't divide the 5 out, can't divide anything out except for 1, which is pointless at this point in time. So we're going to do the AC method. So what's 5 times 9? 45. Now again, you have a positive product, but a negative sum. That means both of these, subtract purple, both of these are going to have to be negative. Because a negative times a negative is a positive, but a negative plus a negative is a bigger negative. Not 9 times 5 is 45, but 9 plus 5 is 14, so that doesn't work. I'm going to go 15, negative 15, and negative 3. Negative 15 times negative 3 is positive 45. Negative 15 plus negative 3 is negative 18. So I'm going to separate these out into negative 15x minus 3x. All right, and then you group it. So I get minus 15x, negative 3x. Now looking here, what is the greatest common factor that you can factor out? Can I factor 5? Does 5 go into 5? Yes. Does 5 go into 15? Yes. So I'm going to factor out a 5. Looking here also, Do they both have 1x? Yes. Do they both have 2x's? No, only this one does. So the greatest thing I can factor out is a single x. I'm going to factor out a single x. So what's 5x squared divided by 5x? Well, 5 divided by 5 is 1, and x squared divided by x is just x. What is negative 15x divided by 5x? Well, x divided by x cancels out, all right? And negative 15 divided by 5 is negative 3. Okay, this time I can factor out something other than 1 because negative 3 also goes into the 9. I can't factor out an x though. This 9 doesn't have an x, so I can't factor out an x. All I can factor out is a negative 3. And again, I don't want that front number to be negative, so I factor out the negative with it. So what is negative 3x divided by negative 3? Just x. What is 9 divided by negative 3? Negative 3. And again, you should be seeing that this and this are the same. If they're not the same, you've done something wrong or this method doesn't work. And later on, again, in later videos, I'll be doing the quadratic formula. So if the AC method doesn't work, then honestly, the solutions are probably imaginary and you're gonna have to use the quadratic formula. So those should be the same. And if they are the same, then you can copy down this factor x minus 3. And the other two parts become the other factor, 5x minus 3. And now you factored it. Now you factored it. I think this is the last example for this video. Yep, it's the last example for this video, part 1. So I switch it up. This time we have to still use the AC method, but there's a GCF, which we can factor out first. Now I can't divide out a 15 because 15 doesn't go into 27 and 15 doesn't go into 6. But 3 goes into all these numbers, so I can factor out a positive 3. Now I am just going to write that in all the way down here because we just have to keep it out there because we're not solving. Now in the next video, you're going to see that there's a way that we can just get rid of it and not have to deal with it anymore. But for factoring, you just got to leave it on the outside. So we're not even going to think about that 3. It's just sitting out there being multiplied, but we're not going to touch it. All right. So now that we factored out the GCF, which was 3, we now have a quadratic, which still has an a value greater than 1. So we're going to use the AC method. 5 times negative 2 is negative 10. One number is going to be negative because that's a negative product. And I'm going to say, because I want it to be negative 9, I'm going to say negative 10 and positive 1. Because negative 10 times 1, negative 10. Negative 10 plus 1, negative 9. So I'm putting 10x. Oh, and it's really important. And actually, well, it's too late now. I wrote it in pen. This works out whether you put the negative 10, whether you put this number first down here. I could have put negative 10 right here and it still would have worked fine. All right. You might have had to divide out different numbers, but it would still work. Or it should just still work just fine. Again, if it doesn't work, then it doesn't factor and you have to use the quadratic formula. So I'll put positive 1 here. Okay, so let's group them. So we get negative 10x and we get positive 1x there, minus 2. So again, not looking at the 3, just looking at this, what can I factor out of that? So what's the greatest common factor there? And the greatest common factor there is 5x. I can factor out a 5x. 5x squared divided by 5x gives me x. Negative 10x divided by 5x is just negative 2, minus 2. So x minus 2. Now here, if you notice, I already have x minus 2. Technically, there's this positive 1 in the front, but that's just 1x minus 2. This is 1x minus 2. So I'm just going to drop the 1x minus 2 down. And just like that other time when I couldn't factor out GCF or a number that was bigger than 1 GCF, that means just take out a 1. Just factor out a 1 plus 1. All right, x x divided by 1, x. Negative 2 divided by 1, negative 2. It doesn't change anything. So I get my x minus 2 right here, and I get my 5x plus 1 here. Now again, doesn't matter. I could do 3. It would be totally okay to do 3 times 5x plus 1 times x minus 2. And this is the answer you would get if you would have switched these two in the beginning, I think. I'm pretty sure. If you would have switched these two in the beginning, this is what you would have gotten because you flipped them around. So hopefully that helped. I mean, we're going to do more of it in part 2. So if you're going to watch part 2, we're going to do the same stuff, but add to it. So the problem's going to get a little bit longer, which means I'm going to have to zoom out. So thank you for watching part 1. I hope you watch part 2.